Hello friends, I am here to discuss a very interesting problem. Like generally what we study in our class 12th, 11th and furthermore also that a pendulum is oscillating under gravity like this. So it will oscillate under G and we write equation like this, like let's say it has moved from mean position to theta position. That so at that moment, at theta position, the force under gravity will be applied here in mg and in tangential direction mg sin theta will be there. So what we write generally that m theta double dot, if someone want to derive it from the in starting position, then I can do it. Like let's say we can take a force torque. Okay, torque will be mg sin theta. This is L, so it will be like mg sin theta into L, and the moment of inertia will be ml square. So we can write I theta double dot. Okay, means I theta double dot means I into alpha equal to torque. Okay, so torque is in opposite direction, theta is increasing. Okay, so we can write ml square theta double dot equal to minus mg sin theta L. So mg sin theta will come in this side, and m and m will be cancelled out, and one L will be gone. So L theta double dot plus g sin theta, okay, will be there. So we take it as theta double dot plus g upon L sin theta equal to 0. So we can write from this place that omega, natural frequency, will be square root g upon L, and we can also write t, time period, will be 2 pi square root of L upon G. Okay, so generally we do this thing on such a way, like if a pendulum is oscillating under gravity, and so the equation of motion will be like theta double dot plus g upon L sin theta equal to 0, and omega we can write square root g upon L, t equal to 2 pi square root L upon G. So, okay, so it's like normal thing we do in class 12th, 11th also. But the thing what I want to convey you, that we can imagine a hypothetical case where G changing with space. Okay, so here we are considering a particular value of G at every position. Okay, so if every position you are considering G, so time period and omega also will not change according to the space. But imagine something, a hypothetical case. So I have made it here. Let's imagine a hypothetical case where Earth is like this is the mean position. Okay, this is Earth. This is Earth. So imagine a hypothetical case where in the right side density is more. Okay, density is more, whatever it may be. So okay, if density is more, then I'm considering it as a hypothetical case, it may be something else. So it has made the gravity as 5g on the right of the mean position, and let's imagine something density is less on the left side. Okay, so the gravity on the left side of the mean position will be g. So how interesting that like this motion will be, that g is not constant over a space, g is changing with the space. Okay, and we can also make it complex, but initially we are talking about very simple problem. Like about this mean position, like right of this mean position gravity is more as 5g, and left of this mean position gravity is g. So it looks very interesting because many things changes just about this point. Whenever this mean position is like about this mean position, many things will change. Like right of the mean position, frequency will be different, time period will be different, and just left side of this mean position, frequency and time period will be different. So it may be complex, like we can make gravity changing with left to right. Okay, let's say we can make it. So first we will discuss about this problem. So we will simply find out that just for the left side, omega will be square root of g upon L, and time period we can find out is 2 pi square root L upon g. And for in the right direction, omega will be square root of 5g upon L, and t will be 2 pi square root L upon g. So it looks very interesting, like whenever this bob will cross this mean position, suddenly at that moment omega will change, like omega will be increased. Okay, and time period will be reduced. So it's interesting, and we can make it more complex, that let's say a bob is there, a bob is oscillating there. Okay, and what we can make, and what we can talk about, that let's say this is x position, this is the extreme of this bob. So x direction, y direction, gravity is changing with x. Gravity is a function of x, so we can make gravity as a function of x. So for the simple case, we can imagine gravity as a gravity is varying linearly. Okay, we can make it a plus bx. So gravity can be a we can take as 10. Okay, and b we can take as 2x. So gravity will be increasing from this left side to right side. So how gravity will be changing at that moment, I can draw the graph. So here, so gravity will start at from this is g and this is x. Gravity will start from this 10 meter per second square, and it will vary linearly from left to right. Okay, so let's say this length is about I can say 5 centimeter. Okay, we can make it more also. Let's imagine a hypothetical case. now let's say 5 centimeter. Okay, so this at this moment, this will be, gravity will be 10 plus 2 into, so we have to make it more, because it will be very less, 200. So here we will write 0.05 meter. So this will be 5, sorry, this is 200 into 0.05, so it will become 10, sorry 20. So at this moment, at this point, the gravity became 20 and here it is 10. So it is varying linearly. If it is varying linearly, then also it is a more interesting case that here gravity is changing with position, the continuous, it is a continuous function of x. So omega will be varying from left side to right side. It will be like square root of g upon L, but g will be a function of x, so omega will be a function of x. And time period will also vary, like L upon G, two pi square root of L upon G. G we can write 10 plus 200 x. So it's very interesting to see the result that omega is continuously increasing. Omega is continuously increasing from left side to right side. Just here I want to put this problem in front of you, that it looks very fascinating, that hypothetically we are imagining that G is changing with space in x direction. So furthermore we will discuss about it, and at that moment we will discuss about velocity also, displacement also. But here at this moment just we are dealing with something omega and time period. But what I can say, I may be wrong somewhere. If I am wrong, then comment on the comment box. So I will try to rectify that problem also if I will be incorrect at that somewhere. But hypothetically we are imagining this problem that G is changing with time, space. Okay, thank you.